In this week's episode of the AWS Developers Podcast, we're talking about OAuth 2, and one of the very specific usage of OAuth 2 is the machine-to-machine authentication. Thank you for listening to the AWS Developers Podcast. We're available in all your podcast application, all good podcast application. Every Friday morning, there is a new episode, either with a customer to discover a use case, either with someone from a service team to dive deeper into one or the other AWS services. And today, I'm very pleased to welcome Abram Douglas, your senior solution architect in the Amazon Cognito team. We're going to talk about Cognito and one very specific use case, which is machine-to-machine communication. Maybe why? Let's start. What is the problem customer are trying to solve here?
Yeah. So glad to be here. And from when it comes to machine, I like to describe even what that is as it's the authentication of the process of verifying the identity of a device, service, or a non-human automated process. So you can almost think of machine to machine could be a machine, it could be a device, it could be a service that ultimately needs to communicate with another machine, another service or device. And
Without human intervention. I mean, it's not me behind the keyboard making an action on my application that causes an API call. It's really like an application doing some computation, a batch job, or you mentioned a device, so it might be an IoT device communicating back to a backend.
Yeah, absolutely. I think that's the most important aspect here is it's non-interactive. So there's not a human who's actually taking an action to perform this back-end authentication. It really is the back end of an application. So there's a front end we're familiar with interacting with, but as I'm doing something with that front end, on the back end, there's something happening. So we can almost imagine that back end needs to access maybe a third-party system or an additional database system or something else, and that now is where that machine to machine off takes place.
And most of the case, it might be synchronous over HTTPS, but that's not mandatory. The use case here, it's really broad. It might be asynchronous communication over SQS. I mean, it's totally disconnected from the transport, from the physical protocol that these two machines or these two applications use to communicate together.
Right. You're absolutely correct. There's there's going to be a lot of different use cases that may require different types of technology and different ways of authenticating that machine to machine type of authentication. But that's going to depend on the use case. So I think we're going to dive deeper into
Mhm.
some very specific things. But yeah, it's
But I know how to do that. Come on, I'm a developer. I know API keys. If I want to interact with a SaaS service, I register on the website. I receive an API key. I put the API key in my app, and voila. Why do we need something else?
Yeah. So there's definitely some different ways of performing M2M and machine to machine authentication. So API keys is one of those, right? So I think this is very common. It's quick, simple,
Yeah, it's
easy.
easy.
But it has some risks that come with it. It's a long-lived credential,
Mhm.
and you're actually sending that API key with every request. So it is actually communicating to that backend service and continuing to use that API key.
It means that if someone intercepts my communication, it captures the API key, and then that system or person can reuse the API key because you said it's a long-lived credential, so it's not changing.
Correct. Yeah, that's definitely a risk that does exist. And there's some other controls you can put in place around API keys, maybe allow listing the client to actually even call the service, right? So there's other controls and mechanisms, but API key is long lived, and it's used for every single call. And then we have an alternative to that, right? And that is using the client credentials grant, part of the OAuth 2 specification. So this is really where we want to dive into and where Amazon Cognito can help customers with this use case. And with client credentials, instead of a single long-lived credential used all the time, with client credentials and using Amazon Cognito, you actually will create a client ID and a client secret. So
On the
now
server
those
side,
on the
on
server side,
Cognito. Mhm.
correct. Now that client ID and client secret is used to still communicate between the backend service into Cognito, but what is returned is a temporary short-lived access token. And now that authenticating machine or service can use that access token to go ahead and call the downstream resource server. And therefore, that is what's being communicated across the wire. That's what's being communicated with the secondary or third party service. And it's time bound, it's temporary, and you can customize that as need be dynamically based on different scenarios going on.
And that's super important what you say. It's time bound, so it's limited in time. Typically, what are we talking about? A few minutes, a few hours?
Yeah, yeah, and this is where customers would definitely define their own requirements.
Mhm.
But Cognito, we can go anywhere from 5 minutes up to 24 hours. So you can define that time frame.
And it's not your secret. I mean, your secret, like an API key, um, is not exchanged with the downstream services. It's that temporary token that is generated by Cognito that the client application will send to the server application. So all the server application will receive, it's a token. So a token, it's a like a base64 JSON on code signed something. That's what they are going to receive.
Yes, yes. Now, there's one key thing that is very important a part of this because there still is the issuance of client ID and secret. So that still has to be secured in the back end of that application and workload. So using something like AWS Secrets Manager or any type of privilege access management product that can secure these type of credentials, you would still house those there, and then they're used and obtained just in time along with Cognito to now get back that access token. And the downstream service, the resource server in this case, they would just receive that access token. And that access token does comprise a header. It contains a body which contains the claims and then has a signature on it. So there's a way to cryptographically verify that that token has not been tampered with, and then that downstream resource has access to those claims within that token, which really define who is this user, what access do they have, and now that can be enforced within that downstream resource.
It's super hard to talk about user authentication flows on an audio only podcast. You need to imagine you have a whiteboard in front of you. On one side, you have your backend application that needs to call an API, which is on the other side, like left side, the backend application, right side, the API. And on top of that, you have Cognito. You, as a user, you define an application in Cognito. You, as an admin, you define an application in Cognito. That application is defined by a client ID and a client secret. Your backend needs to securely store, and that's why you mentioned Secrets Manager or the way to store that secret. But let's say once a day, the backend needs to call Cognito to say, hey, give me a token for that client ID and client access. And Cognito will deliver a signed token containing some claims. I have questions about claims a bit later. And now the backend on the left side of the whiteboard can use that token, embed the token, might be an HTTP header, might be a different way to transport that token to the other backend, the other application that will verify that token. Is it a correct mental picture of the flow as much as we can do with voice only?
Yeah, no, that's a perfect mental picture. I think I like to also think about, let's imagine we had like a chat type of application. So some user goes and logs into a web application and there's a chat interface on it. I
Mm-hmm.
imagine this is a very common thing. It's growing,
Mm-hmm.
right? We're seeing a lot more. And by interacting with that chat interface, on the back end, it may be needing to actually go off and get data in another system. So you can imagine almost on that right side of this whiteboard we're imagining, um, that's really where the back end of this chat interface would go and get this temporary token to now access this third party or external data, or even data still within the system itself, but it has this temporary token to do so.
So when the client backend, the client part of the backend is asking Cognito for a token, can it give a bit more information than just the client ID and the client secret, like the token, the identity token from the user which is currently connected, or some kind of other context, so that Cognito can issue different types of access token?
Yes, yes. And this is now, that's the perfect way to almost expand the thought of this chat application.
Mm-hmm.
So with Amazon Cognito and using that M to M authentication and authorization flows, you can actually pass in metadata from the client. So this could be anything you define, or it could even be the access token from that human user who authenticated. So whatever identity provider is being used to authenticate that user, whether it be Amazon Cognito or another third-party identity system, that access token can be passed in as context, and now the backend can persist the context of that access token to Amazon Cognito, and it can take the content of that token and customize an access token to be returned for the backend to use.
How does that work on
S-
the Cognito side? If I'm the admin of Cognito, how can I configure Cognito to say, hey, take the context there and use some maybe custom logic to generate a custom a specific claim in the token? Is it like a Lambda function that you need to deploy with a specific interface, or code inside Cognito immediately? I truly don't
Yeah,
know.
yeah, yeah. No, this is good. And so Amazon Cognito has what we call Lambda triggers, and there's several different Lambda triggers that exist. And this is a way of thinking how you can really customize different flows. So everything from pre-sign up to post authentication, even some Lambda triggers to help migrate users if you have user use cases. But when it comes to customizing a token, we have a Lambda trigger that we call a pre-token Lambda trigger. And ultimately, it is a Lambda function in the backend, and you're able to invoke this Lambda function just before an access token is returned. So in our use case here, the back end of our workload and application is obtaining obtaining the back end of our application is obtaining the client ID and secret, calling Cognito, and supplying the metadata at the same time.
In the
Cognito
same
will
call, in the
in
same
the
API
same
call.
call,
Okay.
yeah, in the
Mm-hmm.
same call. And Cognito will first verify that client ID and secret that it's valid, and then it has that metadata now that is going to be persisted to this Lambda function. So now in the Lambda function, this is where you have the ability to fully customize whatever it is you want to do.
So it's Cognito that calls the Lambda function, passing the context to the Lambda function. And then it's your code running in the Lambda function.
That
You
is
do
correct.
pretty much what you want.
Yeah,
Mm-hmm.
you can do pretty much what you want. So the nice thing is this is just a native integration between Amazon Cognito and AWS Lambda. So it is Cognito that's going to invoke that Lambda function, and all of the context of this authentication event is passed into that Lambda function. And so
And the Lambda function needs to return a specific payload or a specific format that will be embedded inside the token, or it needs to generate a full token that will be just signed by
yeah,
Cognito.
yeah. So the nice thing is you just define what claims. So we'll
Mm-hmm.
bring back up claims, right? You define in that Lambda function what claims you want to either override, suppress, or even create custom claims. And you're just passing that payload right back into Cognito. And then Cognito is actually going to formulate, it will sign and generate that access token and return it ultimately to the client.
What is a
But
claim at technical
yeah,
level? It's a string.
so so a claim ultimately is like an attribute within an access token that really the defines the
The permission that we want to give to the system.
yeah, so a claim ultimately describes who the client is in this case,
Mm-hmm.
and the access token can use those claims to define what type of access does this entity have by way of the claims.
Can
I'm gonna
you
have to
give an example of
yeah.
a claim?
Yeah. So a really good example of a claim is just simply um, a very standard claim is called a sub.
Mm-hmm.
And sub is short for the subject. So the subject or the sub claim is
Typically,
really
it's the identity.
defining who is this
Mm-hmm.
access token belonging to? Who is the underlying identity of this access token? So sub is a very more describing type of claim.
And this one is standard. It's part of OAuth. It has been codified. It has to be called sub. But if I want to put a custom claim, what would be a typical custom claim from a customer?
Yeah. Yeah. So a good example could be you may want to create a custom claim called on behalf of, all one word. And in the context of what we're talking about, you can create a on behalf of claim, which could now have subclaims within that to describe who the human user is. And so an example here now is the human user has logged into the application. Their access token has been provided as context and metadata
The access token that they receive from their identity provider.
from
So here
their
we are
identity
talking about
provider.
Okta, an Active Directory, anything.
Correct.
Mhm.
Anything, any identity provider. And now in that Lambda function, you could actually define and say, I have this access token. In that Lambda function, it can be decoded because it is base64 encoded. So you can decode that and you can see all the claims. And in that Lambda function, you can grab data from the access token from the human user and now generate custom claims for the access token for the AI agent or the backend or the machine to now use.
Yeah, so at the end, the downstream system that will receive the access token generated by Cognito will contain whatever your Lambda function decides to inject into the claims there. So the claims might identify the end user, its role, and some access decision or authorization decision can be taken based on the content of that token. That's pretty much clear on the token generation side. How that token will move from one application to the other. It's outside of the scope of OAuth and Cognito. It might be SQS, HTTP. We mentioned that already. Now let's look at the receiving part, the server part that receives that token. We're going to talk about API gateway. That's one very easy way to consume this token. But let's imagine first that I'm not using API gateway. I have my own backend application, a good old Java application with Spring Boot, for example. So I receive that JWT token. How can I verify it? Is it just verifying the signature, or do I need to call back Cognito to verify, hey, is it a valid token from you?
Yes, yes. So part of OAuth and one of the key things around just OpenID Connect and OAuth 2 is it's issuing this stateless token, right? So this access token we're talking about is entirely stateless. But
Stateless means I don't need to contact the issuer to verify its legitimacy, its
it's more,
identity.
yeah, it's more stateless in the sense that there isn't a need to make a call back to Cognito or back to the identity provider
Mhm.
to just verify, is this still active? Is there still an active session, right? There's no concept of session.
Obsession.
It's
Yeah.
more of,
Mhm.
hey, you have a stateless issued access token, but you do still need to verify it. And how this works is with Cognito, we do issue the JSON web key set. And so this is known as the JWKS, so the JSON web key set. And what that key set contains is the public key that was used part of the key pair to sign that access token. So this is the verification aspect of it. So that backend server can either make a call to get the JSON web key set. It's probably best practice and some guidance to actually cache that just
Yeah,
locally
to
on the
not do
service
that
so
at
it's
every
there.
call.
Exactly,
Mhm.
exactly. And then with that, you can now see the public key that was used. And by way of using the public key, you can actually verify that the token has not been tampered with and it's still signed from the original private key that issued that access token.
Yeah, it is
So,
just quote quote verifying a digital signature. You have the signature in the token, you have the public key on the other side, and there are tons of libraries that do that for you. You practically never have to write the low level code to do that. Whatever programming language you're using, Python, JavaScript, TypeScript, even Swift. I played with Swift token the other day. You use high level libraries that will verify the signature for you.
yeah, absolutely. Absolutely. That's something you definitely don't have to worry about, coding out or building yourself. And in fact, there's a really great library out there, just simply called AWS-JWT-verify. So this is something that's, very nice out of the box where you can just supply a token and be able to verify whether it's a valid token or not. So yeah,
For what programming language?
this is for JavaScript. It's written in
Okay.
Node, and so it can be used for any Node workload.
and it's linked in your podcast application. If you scroll down a bit, you will find a link to the GitHub repo for this library. The server application, once it verify the authenticity, the validity of the token. So there is the signature, there is the expiration date, I guess, to verify as well. Is this token still valid? Then it can read the claim section and apply whatever authorization logic based on the values that are in the claim. That's how it works.
Yes, yes. So you touched on some key things there. So we're verifying the signatures. That's good, but we also want to make sure the token's not expired. That's
Mm-hmm.
another important thing we want to do. And then when it comes to actual authorization, this is where a lot of those claims can help. So we could have a very basic, sometimes we'll just call coarse grain authorization, where only a certain subject, kind of the claim we talked about earlier, can actually perform a certain action. So that can be sort of a very basic scenario where we can also now get into more fine grain authorization where maybe we look at not only sub, but maybe we look at um, another claim that maybe contains the application in which issued this access token. And then now that underlying server can actually verify, does this token have the claims I'm expecting in order to actually perform a certain action?
But that's totally on the application side. I mean, it's outside of the OAuth2 protocol.
Yeah.
It's your code, your implementation. You implement whatever authorization logic that you want to do. But most of our customers are not doing that. They are using like a managed service to expose an API gateway. I'm looking at you. So API gateway make that easy for our customers.
It does. It does. I think API Gateway is a great just native solution. There's a native integration between Amazon Cognito and API Gateway, and you can use something called a Cognito Authorizer. So that is a very great way to do that very coarse grain authorization. Can this API be accessed or not? I feel if there's still a need for fine grain authorization, you may need to move away from a Cognito authorizer and use either a Lambda authorizer, or you could actually combine that with another AWS service called Amazon Verified Permissions. So that's another service where there is an integration as well, where you can define policy there and make a is authorized API call, and policy will be evaluated whether or not a certain action can be taken by a certain principal.
Let
So
me recap. Inside API Gateway, I can define an authorizer. And there are three types of authorizer, you said. There's a Cognito one, where as the API Gateway developer or administrator, I just define the name of the Cognito user pool that I want to connect to. And then API Gateway will itself verify that the token is present in the request and is correctly issued by that Cognito user pool. That's probably the easiest one because there is no code to write. But it's very coarse grain, as you said. It's a go no go decision. I let the request go through, or I stop the request at the API gateway.
correct.
Second way, it's the Lambda authorization. There, API gateway delegates the authorization decision to a Lambda function, and again, it's your code. Your code will receive the token, and it's up to you to implement whatever logic you want into that authorizer. If I remember well, but I speak under your control there. There are two types of authorizer as well. One that just basically say yes or no, and one that can return an IAM policy that can be propagated downstream to the whatever is behind the API gateway. Did I remember well? Do I have that part correct?
I would, yeah, I would say the two authorizers in the API gateway you described are correct, right? The Cognito authorizer,
Mm-hmm.
very coarse grain, and then there's the Lambda authorizer, which is really your own code and you define and design whatever that would be. I would think the other piece of this is using Amazon Verified Permissions. Now,
That's the third aspect, which
right,
is
right.
way more detailed because AVP, Amazon Verified Permission, will also check if that specific user with the sub and the claims has the right to call that specific API, the HTTP verb, the path, the parameter. and you can define policies inside AVP. So it might be really, really, really detailed and fine grained.
Yes, that's definitely the case, but customers will still even use AVP for just like what we'll call like role based type of access
Okay.
or even attribute based. So it actually can cover all use cases that are a little bit more coarse grained and get very, very fine grained as well. So it kind of covers um, a lot of different use cases for all types of authorization. But what's interesting is you could use AVP within that Lambda
Ah,
authorizer as
yes.
well.
The Lambda function can be a client of AVP
Correct.
to evaluate a
Right.
policy. But the cost of these three options are totally not the same.
Yeah,
Uh,
there's definitely going to be some varying costs between all of these scenarios and options. I think the most important thing is really, starting from requirements, starting from security, and working backwards from there, and then being able to understand, which use cases, which solutions align, and then you can think about optimization around some of this.
One of the things I
Um,
like with API Gateway Cognito authorization is I don't have to code anything. It's the API Gateway that will verify the token for me. If my Lambda function behind the API Gateway is called, I know that the verification has been done already. And yeah, I don't have to focus too much on that
Yeah,
aspect,
yeah. It's definitely a good, and there's always hybrid type models, right? So
of
there are
course.
a lot of customers who will stand up the API gateway up front, and therefore it's doing that checking, making sure the token's not expired, the signature is still good. So it's taking care of all the verification pieces. And then maybe more further in the back, and that's now where like the fine grain authorization could take place. So like you said, I already have verified the token, so I'm happy with that. Now let me just look at the claims and actually do more fine grain, more granular authorization, whether something can or cannot happen.
As a solution architect, you're working with our customers, so you see different use cases. What are the best practices, or maybe the opposite, the alternate question? What are the things to not do? What are the do and don'ts when deploying this type of architecture?
Yeah, yes. And, we actually mentioned a few of these throughout our talk, right? But I think it is good and important around just security best practices. And right up front, we spent some time on this, is just always verifying tokens, right? So
Mm-hmm.
whether you use API Gateway to help with that or you're verifying in your application, you want to always make sure you verify the tokens. And again, checking for expiration, checking the signature. I think it's also very important that you use like things like AWS WAF, Web Application Firewall. So if you're using Amazon Cognito, Cognito has a native integration with WAF. So this way, your applications, your workloads, your AI agents, anything that's actually making the call to Cognito to get a token, you want to have a WAF on there so you can actually secure the calls to your Cognito endpoint. And this just allows you to have various web ACL rules to either allow or deny, and just lock down who is actually making calls to your Cognito endpoint. I think another one we touched on also is just always using some way to secure the client ID in secret. So AWS Secrets Manager is a perfect place. Um, if we think about some of our use cases, if there is ever a backend process or maybe an AI agent is using some type of orchestration lambda, you want to make sure that that orchestration lambda, when it goes to get an access token from Cognito, that it would first reach out to something like Secrets Manager, get client ID in secret just in time, and now use those credentials to get a new access token. So again, just really securing the client ID in secret.
Is there an easy way for customer to rotate, or is it recommended to rotate the client secret like we do for database password, for example?
Yes. So one key thing here is, using something like Secrets Manager, you don't want to hard code what the client ID and secret is.
Mm-hmm.
So that's a nice advantage that comes with this. And it is definitely a consideration and a best practice to actually, rotate a secret, every once in a while, whatever your security requirements are. So the nice thing is if you do rotate or change a client ID and secret, you're really rotating that in Secrets Manager, or whatever privilege access management solution.
Yeah,
So
that's the
therefore,
way
at
to
runtime,
distribute.
Yeah,
the data to everybody. But then it means, and my question was, is there an API on Cognito to change a client secret or to regenerate one as well?
rotate or change that client ID and secret, you would create a new client ID and secret,
Mm-hmm.
and you would now get those credentials into the secrets manager. So your workload just now gets the latest and greatest client ID and secret.
And is there any recommendation about the frequency of that? What our customer, what do you observe with our customer? They are doing that like every month, every 6 months, every 1 year. It depends on the workload, I guess, in the industry.
Yeah. So this is where there's definitely a lot of different things being done across
Mm-hmm.
customers. I would always say that depending on the security requirements in your organization, or maybe even the industry you're aligned to, there could be regulatory compliance around how often something may be rotated. So take guidance
Mm-hmm.
from that really around what should be done, and then whatever your internal security requirements
Yeah, we
are.
cannot make recommendation. It really depends on your industry and the type of workload that you're operating. That's a
Correct.
fascinating conversation of how two systems can authenticate by exchanging tokens in between two different backends. When we think about system talking to each other right now, we also talk about AI agent. You mentioned that several times. Is it one of the future direction for this two machine to machine flow? How do you see the future?
Yeah. So, I don't think we could have any type of technology conversation today without mentioning, AI and AI agents, right? It's a hot space right now. And I think the future is that there will be more building and usage of AI agents. And we're also going to enter the world where those AI agents are needing to access data on behalf of users, right? And this may be data that lives within the domain or within the
Mm-hmm.
environment of where this workload runs today. So it may be all within AWS, for example, or it may need to access some set of data that lives outside of the environment. And this is really now where um, using things like OAuth 2 and being able to pass user contexts and being able to issue customized tokens that represent the user are going to become very important. And also where authorization becomes very important. And the last thing I would say that becomes also very important is ensuring that there is user consent. So before this AI agent goes off and performs an action on behalf of that user, we're actually capturing the consent of that user. And now the AI agent is able to go and get its own access token to perform actions on behalf of the user. So this is a use case I think that is starting to grow a lot of interest in customers, and definitely want to make sure you're still securing those workloads.
Yeah, it also reminds me the trusted identity propagation discussion that we had previously on this podcast as well, where
Mhm.
how to propagate the identity of the user, which is behind the keyboard, down to any downstream system. At that time, we were talking about more S3 and Redshift, but no, you're right. With AI agents, we want to propagate the identity to the AI agents to know what type of data we can retrieve for that specific user and the permissions that he has. Yeah, the future is bright. we need to have more episode later to talk more about this. Thank you very much for having explained this quite complex topic. It's never easy to explain O2, especially without a whiteboard or a diagram. Abram Douglas, your senior solution architect in the Amazon Cognito team. Thank you for having listened to this episode of the AWS Developers Podcast until the end. And now go build.